fraction, addition, and subtraction. In order to add or subtract fractions, you have to have common denominators. So here, if A, B, and C are numbers where C is not allowed to be a zero because it's going to be in the denominator, if you have A over C and you add B over C, as long as these denominators are the same in your fraction, you can add the numerators together and keep them over the same denominator that you had over here on the left. And the same holds true with subtraction. Now, so what happens when we don't have common denominators? You want to find what is known as the least common denominator, the LCD. The LCD of two fractions is the smallest number that can be used as a common denominator of the fractions. In other words, usually what we say here is what number can both both denominators divide evenly into. And if that's the smallest possible value, that's your least common denominator. And then you'll also see the least common multiple, which is the same as the least common denominator. Multiple means what's the smallest number that both those numbers are factors of. And factors means to multiply when we're working with their denominators. All right. So how do we add and subtract fractions? Do they have a common denominator? Yes. Go to step 2, add or subtract the fractions. Simplify if possible, which means can I reduce the fraction? If the answer is no, then we have to find your LCD and create new fraction. Now what I want to show you here, and I think this is very helpful because sometimes we forget that we have to have common denominators. And if things don't look right, let me give you an example of what I'm talking about. I'll show you a very straightforward problem here. Okay, so what do I mean? Well, here you have 2/3 plus 1/2. Now, if you think about what is the value of 2/3, it is bigger than a half because half of 3 is 1.5 and 2 is bigger than 1.5. So 2/3 is bigger than a half. And if I add these together, this should be bigger than a whole. And it's amazing how many times I see people do this. They add the top, they add the bottom, and that's not bigger than 1. We said it's going to be bigger than a whole. So if something's not looking right and you can't quite remember, oh man, what's the rule on how to do this again? Draw yourself a picture. Pictures are worth 1,000 words. Don't use circles. Use a square. So, for example, I'm going to go to my 2/3 and I'm going to draw a square. And I am going to break this into 3 equal pieces. And you can do whatever you want here. If you want them to be vertical lines or horizontal lines, I don't care. So let's say we're going to go 3. We're going to put in 2 vertical lines to break that into 3 equal pieces. All right, so let's shade it. So what I'm going to do is I'm going to shade it in a different color here. We're going to shade it in blue. So this would represent 1/3. That's another 1/3, which represents a whole 2/3. And then I'm going to do the same thing with my 1/2. Same size square. Keep it the same. Now we're going to break this in half. But on the second square, don't go vertical lines, go horizontal lines. Okay, and again, I'm going to color in 1/2. Now, as you can see, this is bigger than half. This is a half. You should get something that's a whole. Well, here's what we're going to do. You got to have common denominators. So you're going to take this red line that you just drew over here in the second square. You're going to draw it over here in the first square. And then you're going to take the two vertical lines that you put over here in the first square, and you're going to draw them over here in the second square. And now if you look really close, I have formed all these little rectangles in here that are all the exact same size and shape. Okay, well, there are 6 rectangles in each fraction here. So that means my new common denominator is 6. And when I add them together, my denominator will still be a 6. Well, here, how many rectangles are shaded? There's 4 of them. That's 4 over 6. Here's 3 over 6. Now 4 plus 3 is 7 over 6. That's my final answer. And 7 over 6 is definitely greater than 1. So that's how I find my answer. So if you're not sure, go to a picture and get an idea of how to conceptualize what's really going on. Okay, so what has happened? How can I avoid now looking at drawing out all these squares? Because what happens, well, if my denominators start to get bigger. So for example, maybe you have something like 3/5 plus 2/7. That's a lot of lines and rectangles to draw. Well, let's go back up top and see what happened. Here I went from a 3 to a 6. Okay, how do I get there? I multiplied by 2. So I really take this denominator right here and multiply it to both the top and the bottom. That gives me the 4 over 6. And then, where did I get 3 over 6? Well, I took this denominator of 3, multiplied it to the top and the bottom of the second fraction, and that gives me 3 over 6. So if you forget how to do the rule, draw the picture, see the pattern, but then you want to go back to, if you will, your algebraic rules to adding fractions. I kind of call this the crisscross multiply of the denominators. You take the first denominator, multiply it to the top and bottom of the second fraction, take the second denominator, multiply the top and bottom of the first, and you're good to go. You've got your new fractions, and we can multiply it. So here, you would take the 5, multiply it, top and bottom of the second fraction. Take the 7, multiply it, top and bottom of the first fraction. It doesn't matter if you put it in the front or the back. So this gives you 21 over 35 plus 10 over 35, which is 31 over 35. And what I like to do is, a lot of times when I do this, is I just write it as one big 35 and go 21 plus 10 and get 31 over 35. If you want to write 2 denominators, you can. I'm always looking to save time when I do this. All right, so let's follow that pattern. Let's look at some examples and work through them. All right. Now, I'm using a horizontal fraction bar. You can use a slanted fraction bar. I'm not a fan of that. And let me show you why here real quick. Let me go back and grab my iPad and show you why I'm not a fan of a diagonal fractional. So let's say you had 2 and 1/6. That's my mixed fraction. Now, if you use a slanted fraction bar, step back and take a look. Is that 2 and 1/6, or is that 21 over 6? I'm not sure. So I'm not a fan of that fraction bar. So try not to use that as much as possible. All right. If I'm in doubt, I'm probably going to mark it wrong. So use the horizontal fraction bar. I always say, leave no doubt.